Prepare for an extraordinary and cataclysmic cosmic event that could forever alter our understanding of the universe. Betelgeuse, the colossal red giant star on the outer edge of our galaxy, has begun emitting disturbing signals that suggest it is on the brink of a monumental transformation. Through the advanced instruments of the James Webb Space Telescope, astronomers have uncovered unsettling details about this immense star, and the implications for the future are profound. Astrophysicist Brian has issued a serious and cautious warning as we find ourselves asking, are we about to witness an event so grand and destructive that it could forever change the night sky? Could Betelgeuse soon explode into a supernova, marking the end of its life in a spectacular and unimaginable burst of energy? Let's delve deeper into this incredible celestial mystery and understand what is happening with Betelgeuse, a star that has been the subject of both fascination and concern for astronomers and stargazers alike. Nestled in the constellation of Orion, Betelgeuse is a red supergiant star, massive and ancient beyond our comprehension. It has long been known for its unique reddish glow and its fluctuating brightness, but recent observations have sparked intense interest, especially with the discovery of dramatic shifts in its behavior. At approximately 764 times the size of our Sun, Betelgeuse is an absolute giant of a star. To put this into perspective, imagine a star so massive that if it were to replace our Sun, its surface would extend well beyond the orbit of Mars, enveloping not only Mars but also Mercury, Venus, and Earth. Betelgeuse's sheer size alone speaks to the tremendous scale of this celestial body and the extraordinary processes unfolding within it. However, its size is not the only thing that makes it noteworthy. Betelgeuse is at the very end of its life cycle in a phase known as the red supergiant phase, where it is expanding and cooling after billions of years spent fusing hydrogen into helium in its core. Betelgeuse's age is equally remarkable, estimated to be around 8 to 8.5 million years old. It may seem young by human standards, but in stellar terms, it is ancient. Stars like Betelgeuse have short lifespans compared to smaller stars like our Sun, and its current phase represents the final stages of its existence. It has undergone a radical transformation from a hot blue star to the cooler red supergiant we observe today. As it burns through its nuclear fuel, Betelgeuse is gradually losing mass and undergoing immense changes within its core. One of its defining features is its distinctive red hue. Unlike stars like our Sun, which shine with a bright yellow light, Betelgeuse's surface temperature is relatively cool, around 3,500 Kelvin compared to the Sun's 5,500 K. This cooler temperature results in the star's red appearance, providing astronomers with important clues about its internal processes and state of evolution. Interestingly, historical records have noted that Betelgeuse's color has changed over time. Ancient Roman and Chinese texts suggest that about 2,000 years ago, Betelgeuse appeared yellow. By the 9th century, Arabic astronomers observed its reddish tint, indicating that the star has undergone significant changes over millennia. This color shift is not just a curious historical detail, it offers important insight into the star's evolution and the dynamic processes at play. Another fascinating aspect of Betelgeuse is its variable brightness. It is classified as a semi-regular variable star, meaning that its brightness fluctuates over time in a predictable cycle. This cycle lasts about 400 days, with longer variations occurring over a 5-year period. These cycles of dimming and brightening have been documented for centuries. What makes Betelgeuse truly unique is its occasional irregularity. Unlike many stars that follow consistent patterns, Betelgeuse sometimes deviates from this cycle, showing fluctuations that cannot be fully explained by current models of stellar behavior. In late 2019, Betelgeuse became the center of global attention when it began undergoing an unprecedented dimming event known as the Great Dimming. This sudden and dramatic loss of brightness was so intense that it could be observed by amateur astronomers even in areas affected by light pollution. At its peak, Betelgeuse was losing light at a rate of 0.01 magnitudes per day, reaching its lowest point in February 2020. This change raised alarms among astronomers, prompting questions about what it could mean for the star's future. Here's the thing: when we observe stars, we're not actually seeing them as they are in the present moment. The light we see from stars like Betelgeuse takes time to travel to Earth. Betelgeuse, one of the most fascinating stars in our night sky, is located approximately 725 light-years away from Earth. This means that the light we observe from it today actually began its journey toward us around 725 years ago. In other words, when we look at Betelgeuse through telescopes, or even with the naked eye, we are witnessing the star as it was centuries ago, not as it exists in the present moment. This concept, known as the light travel time effect, is fundamental in astronomy and applies to all celestial objects beyond our solar system. Because of this significant time lag, any sudden changes in Betelgeuse's brightness that we observe today actually occurred in the past. If the star were to undergo a major transformation, such as a supernova explosion, we would only become aware of it centuries after it had already happened. This creates a unique challenge for astronomers attempting to study Betelgeuse's current state. Unlike events on Earth, where real-time observations allow for immediate responses, studying distant stars requires interpreting historical data while making educated predictions about their present and future behavior. Betelgeuse has already exhibited dramatic variations in brightness, such as the Great Dimming event of 2019 to 2020, which led scientists to investigate potential causes including mass ejections and dust clouds. However, due to the time delay in its light reaching us, researchers cannot be certain whether Betelgeuse is already in the final stages before a supernova, or if it still has tens of thousands of years left in its life cycle. This paradox highlights the complexity of stellar evolution studies and reinforces the idea that when we gaze into the cosmos, we are always looking into the past. This time, paradox is an important consideration when monitoring Betelgeuse, but it hasn't stopped astronomers from trying to understand the causes of the star's dimming. A team led by Andrea Dree at the Center for Astrophysics at Harvard and Smithsonian utilized the Hubble Space Telescope to closely study Betelgeuse's outer atmosphere during this event. Their observations revealed that the star's outer layers were losing material at incredible speeds, around 200,000 Baltard. This mass loss was significant, leading to the formation of a dust cloud that partially obscured the star, contributing to its dimming. This mass loss and the creation of the dust cloud sparked speculation about whether the dimming event was a precursor to something even more catastrophic, a supernova explosion. Given Betelgeuse's relatively close proximity to Earth, a supernova from this star would be visible from our planet, offering a rare opportunity to observe such an event up close. Several theories have emerged to explain the cause of the dimming. One hypothesis suggests that the star is going through a phase in the supernova process, nearing the end of its life. Another theory points to the possibility of dust obscuring our view, as Betelgeuse is known to shed material that can form clouds of dust. A third explanation involves changes in the star's photosphere, possibly causing its apparent brightness to fluctuate. Further analysis revealed that the dimming might have been caused by a significant ejection of material from Betelgeuse, which then formed the dust cloud. This ejected material was likely superheated plasma from a large convection cell on the Base star's surface. As it moved outward through the atmosphere, it cooled and formed dust particles, creating a massive cloud that blocked the star's light. The scale of this ejection was astounding, estimated to be about 400 billion times the mass of a typical coronal mass ejection from the Sun. This massive release of material raised eyebrows across the scientific community, suggesting that Betelgeuse could be in the final stages of its life, possibly preparing to explode in a supernova within the next few millennia. The big question remains: when will Betelgeuse go supernova? Some astronomers believe the event could occur within the next few tens of years, while others speculate that it might take up to 100,000 years. Regardless of the timeline, one thing is clear: Betelgeuse is a star in the twilight of its existence, and we may be witnessing its dramatic and explosive finale. Should Betelgeuse explode in our lifetime, it will be a core collapse supernova. This type of explosion occurs when a massive star can no longer sustain its own gravity and collapses under its weight. The explosion will release an incredible amount of energy, more than the Sun will emit in its entire lifetime, and will briefly outshine the Moon, making it visible even during the day. Fortunately, despite Betelgeuse's proximity, Earth will remain safe from any immediate danger. However, the scientific value of observing a Betelgeuse supernova is immeasurable. Studying its explosion will offer insights into stellar evolution, element formation, and the very nature of the universe. As we await this extraordinary event, the night sky may soon be transformed by a cosmic firework display, reminding us of the dynamic and ever-changing nature of the universe.